Students, welcome to MC Square video chemistry class. In this video, we are going to discuss about 4 marks questions, short answer type questions, which are given in the model paper of intermediate board, right? So, section B, 11th question. The first question is, of course, 11th question in section B. Describe the two main types of semiconductors and contrast their conduction mechanism. That is the question. Okay. So semiconductors, two types, you know that. One is N-type semiconductors, another one is P-type semiconductors. So first, what are semiconductors? We write that. Sometimes they ask you that define semiconductors also. Here he didn't ask, but they may ask you. So the conductors, the solids which have conductivity range in between 10 power minus 6 to 10 power 4 ohm inverse meter inverse are called semiconductors. Right? So this is the range of semiconductors, 10 power minus 6 to 10 power 4 ohm inverse meter inverse. So the solids which have in this range, those are called as semiconductors. Okay. Type of semiconductors, already I wrote there, N-type semiconductors, P-type semiconductors, N for negative, P for positive. So what is negative, what is positive, we'll discuss. Okay. N-type semiconductors and P-type semiconductors. First, N-type we will take. Number 1, N-type semiconductors. N-type semiconductors. So the semiconductors in which which have conductivity due to the presence of negatively charged electrons, N for negative I told, right? So you can define like that. The semiconductors which have conductivity, the semiconductors which have conductivity or which contain conductivity due to the negatively charged electrons, is called the semiconductors which have conductivity due to the negatively charged electrons. Okay. So conductivity increases in which, so you can write like that. We'll write like that. The semiconductors in which, this is better, in which conductivity increases due to the negatively charged electrons are called N-type semiconductors. N-type semiconductors. This is the definition. The semiconductors in which conductivity increases due to the negatively charged electrons are called N-type semiconductors. Now, for example, you will take this as first point. The second point, for example, what we have taken here, this is the N-type semiconductors, right? N-type semiconductors, phosphorus, the between that middle one is phosphorus and neighboring atoms are silicons. Silicon belongs to 4th A group. Phosphorus belongs to 5th A group. Means what here? 5th A group elements doped with 4th A, right? Or 14th group. 14th group is doped with 5th A, 14th or 15th. You can say that this silicon is 14th group. So for example, 14th group elements, 14th group elements, example you may write here silicon or germanium doped with, doped means that is nothing but combination, doped with 15th group elements. So example phosphorus or arsenic. For example, 14th group elements doped with 15th group elements. Phosphorus is in middle, that is 15th group. Neighboring atoms are silicons. Okay, just we are doping with 14th group elements. We are doping 14th group elements with 15th group elements. So phosphorus containing how many electrons? 15th group means it contains 5 valence electrons, right? So this is one electron. Here one electron is there, and here one electron is there, and here also one electron. This is one electron of phosphorus. This is another electron of phosphorus, and one more also is there, right? I am writing this free electron. This is called free electron. Okay, and remaining all the silicons are having how many valence electrons? 4 valency electrons, right? So all of them will make bonds like this. All of them will make bonds. Just we have to concentrate where that phosphorus valence electrons, that is important. Here 1, 2, 3, 4. So this is alone now, free electron. Alone is nothing but free electron. That free electron will increase the conductivity. So negatively charged electron increases the conductivity. That is why this type of conductors are called N-type semiconductors. So whatever we discussed now, just now, that only we have to write. So in the third point you can write. How many valence electrons are there? 5. Out of 5 valence electrons, of 5th A or 15th group, out of 5 valence electrons of 15th group elements, here we have taken example as phosphorus, right? Phosphorus make 4 covalent bonds. Out of 5, 4 electrons. Out of 5 valence electrons of 15th group elements make 4 covalent bonds. 4 covalent bonds with what? Neighboring 14th group elements. 14th group is what here? Silicon or germanium. Anything you can take. Elements. That is silicon or germanium. Out of 5 valence electrons of 15th group elements make 4 covalent bonds. 1, 2, 3, 4. But remaining is there, that we have to explain. The remaining 1 electron, the remaining 5th electron becomes delocalized. Means what? It is moving like this in the total structure. Because of that, conductivity will increase. Okay, that is the last point you can write. The 5th electron undergoes delocalization. Delocalization means that will move in the total structure and increases the conductivity. Very simple, right? Increases the conductivity. Then you have to draw this N-type semiconductors. Semiconductors means solids which have conductivity range in between 10 power minus 6 to 10 power 4. N-type means negatively charged semiconductors in which conductivity increases due to the negatively charged electrons are called N-type semiconductors. Now we'll discuss P-type semiconductors. Okay. Second one, P-type. Hope you copied this, or otherwise take the screenshot of this. Then P-type semiconductors. Now we are coming for this. Boron belongs to which group? 3rd group or 13th group. Again silicon only there. Correct. Silicon belongs to, that is maybe 14th group or 4th group, you can say 4th or 14th. Okay. So boron contains only 3 valence electrons. That is containing only 3 valence electrons. So here is 1 electron, here is 1 electron, and here is 1 electron. Okay. And all the silicons are having all the 4 electrons like this. Same as we discussed in the above structure. This is also same. Right, here 2, here 2, here 1, here 2, here 1, 1, 2. No, not 2 here. This is the point. Right. Here silicon has 1 electron, but boron not having electron. Why? Because for the 4 valency electrons of 14th group, there are no availability of 4 valency electrons. Okay. So this is called positively charged hole. P, positively charged. This is the responsible for the conductivity. Positively charged hole. So you can say that the semiconductors in which conductivity increases due to the, now what we have to write here? Due to the positively charged holes. Positively charged holes. Holes means empty space or vacant space, are called P-type semiconductors. Means if you learn that N-type, we'll get the P-type also. Just what I changed here, the semiconductors in which conductivity increases due to the positively charged holes are called P-type semiconductors. For example, what we have taken, for example, here 14th group we have taken, right? So 14th group elements, that 14th group elements now doped with what? Here also 14th group. 14th group elements, silicon or germanium, doped with 13th group elements. 13th means what here? Boron or aluminum. Okay. Out of 3 valence electrons, all the 3 valence electrons are there in the 13th group elements. Out of 3 valence electrons of 13th group elements, that is boron, make 3 covalent bonds with neighboring 14th group elements. Okay, only 3. Means what? The rest of the electron of silicon is not having any pair. Correct? That is why that positive hole is created. So what we can say that the remaining 4th electron, correct? The remaining 4th electron, the 4th electron undergoes delocalization. Means here we have to say that the 4th electron not undergo delocalization, that move towards the positive hole. Here that extra electron is what will happen. This extra electron is trying to come here to the positive hole, because of that conductivity increases. The 4th electron move towards positive hole and increases the conductivity. Okay, that's about P-type semiconductors. In this way, easily you can discuss about that 2 types of semiconductors, that N-type and P-type. We'll go for the next question. Hope you copied this. Right, the next question. Next question has come from solutions. Okay. Solutions. From the solutions, he asked one problem. Vapor pressure of water at 293 Kelvin is 17.535 millimeter of Hg. Very simple problem. Vapor pressure of water. Water means what? Pure solvent, that one. Water at 293 Kelvin is, how much he has given? 17.535 mm of Hg. So here what he has given, I am writing. PO has given. PO means vapor pressure of pure solvent. How much? 17.535 mm Hg. I wrote that. Next, continue the question. Calculate the vapor pressure of solution. Calculate the vapor pressure. Calculate the vapor pressure of the solution. Vapor pressure of the solution means what? PS we have to calculate. PS we have to calculate. He is asking that. Right? At 293 Kelvin only. When at 293 Kelvin, when still he has given some information. 25 grams of glucose. 25 grams of glucose is dissolved in 450 grams of water. 450 grams of water. So water is more amount. Water is in more amount, right? That is why water taken as solvent. Correct? The glucose is in less amount, 25 grams only. That is taken as, that's taken as solute. So weight of solute, or you can say that glucose is equal to how much? 25 grams. Solute is glucose, remember that. And weight of solvent. Solvent is what? Water. Solvent is water. How much? 450 grams. This is the information given. The temperature is 293 Kelvin only, that is constant. Then we have to calculate vapor pressure of the solution. So from which law we can calculate this? That Raoult's law, correct? According to Raoult's law, or you can say that from Raoult's law. Raoult's law, what is that? Relative lowering of vapor pressure. Relative lowering of vapor pressure, that is this one, is equal to mole fraction of solute. That is called Raoult's law. Solute. So number of moles of solute by total number of moles of solution. Number of moles of solute by total number of moles of solution. Solute is what here? Glucose, N glucose. So here N glucose plus N water. You can take that W for water. Okay. So PO value given, yes or no? 17.535. PS value we have to find out. And the number of moles of glucose also we have to find out. So we know that number of moles of glucose you can write. Number of moles of glucose is equal to, what is the formula? Weight of glucose by gram molecular weight of glucose. Weight of glucose given, how much? 25 grams. Gram molecular weight given, 180. Okay, 25 by 180. So 25 by 180 will get 0.1389. Number of moles of water is equal to weight of water by gram molecular weight of water. Weight of water given how much? 450 by gram molecular weight of water is how much? 18. is equal to what? Here, you remember that glucose is nothing but C6H12O6, glucose. And you know that water is what? H2O, water. So based on this, we found that gram molecular weight, oxygen 16, hydrogen 2, 16 plus 2, 18. Here carbon 12, 12 6 are 72. 72 plus 12, how much? 84. 84 plus 16 6 are 96. That is 180, that I have written here. So 18 by 450, we will get 25. Okay. Now all the values we have. Just we have to substitute. PO is how much? 17.535. PS is how much? We have to calculate by, again PO is how much? 17.535 is equal to number of moles of glucose 0.1389 by 0.1389 plus 25, that is equal to 0.1389 by 25.1389. So this 25.1389, 0.1389 by 25.1389 will get the value that 0.0055 is a nearer value. Okay. Here 17.535 by 17.535 will get 1 minus PS by 17.535 is equal to how much you got? 0.0055. Okay. Now PS by 17.535 is equal to what? PS by 17.535 is equal to what? 1 minus 0.0055. 1 minus 0.0055 will get that 0.99. 0.9944. Okay. Now PS is equal to what? Cross multiplication. PS is equal to 17.535 into 0.9944 is equal to 17.438 mmHg. That is the answer. So when you know that formula, easily you can calculate. If you know the maths, you can answer this, not the chemistry. You just remember the formula and just substitute all the values, then you will get the answer. Okay. Now we'll go for the third question. That is the 13th question. It has come from surface chemistry. The 13th question has come from surface chemistry. From the surface chemistry, usually we will expect that catalysis, different types of catalysis you can expect, and you can expect adsorption, physical adsorption and chemical adsorption also you can expect, but the question has come which unexpected. Name any 4 enzyme catalyzed reactions. That is the question. Name any 4 enzyme catalyzed reactions. Right, 13th question. Name any 4 enzymed. Of course, it has come from catalysis, but we will expect that homogeneous and heterogeneous catalysis usually. Enzyme catalyzed reactions. Any 4 you can write. Okay, this is the question. Just you have to remember some enzyme catalyzed reactions. The first one, can say that here enzyme catalyzed reactions, inversion of sugar, you can say inversion of sugar. So in the inversion of sugar, which enzyme is used, that also you have to write. The enzyme inversion, from the name itself you will get that enzyme name also. That enzyme name is invertase. Okay, try to remember this. Inversion of sugar, cane sugar. Cane sugar is nothing but sucrose, right? Sucrose formula is what? C12H22O11. This is sucrose, or you can say that cane sugar. Okay, so this will react with water, then it produces C6H12O6 plus C6H12O6. So here one is glucose, another one is fructose. What we have taken the reactant, this is called cane sugar. Cane sugar. And what is the enzyme we have taken here? Invertase. Here invertase. No need to write again here. Enzyme invertase. Finished. Next one. Conversion of milk. Conversion of milk to curd. Conversion of milk to curd. Here also, this is also one of the example for enzyme catalyzed reactions. So here which enzyme we have to use? Here enzyme is lactobacilli. Lactobacilli. Right? So means milk usually contains that lactose. Based on that, the enzyme name is lactobacilli. Then milk is converting to curd in the presence of this enzyme, lactobacilli. This is the second one. Third one, conversion of maltose to glucose. Maltose to glucose. Can you guess the enzyme here? What is the enzyme we can use? Here enzyme is maltase. Enzyme is maltase. So from the maltose it has come. Enzyme is maltase. So maltose is nothing but C12H22. They may have same formula, but the structure is different. Okay. Maltose with water will give 2 moles of C6H12O6, that is nothing but glucose. Conversion of maltose to glucose in the presence of the enzyme is what there? Maltase. Okay. Next, finally the last one, he asked only 4, right? The fourth one is conversion of urea to ammonia. Urea to ammonia. So here the enzyme is urease. Here the enzyme is urease. From urea we are writing this, urease. So urea formula is what? NH2CO NH2 plus water. So just we are converting urea into ammonia just by reacting with water. So what we get? Already we wrote that. What we are getting here? Ammonia, NH3 plus carbon dioxide. So here CO plus O, CO2. Here to balance that, you have to write here 2NH3 plus CO2. Ammonia has come and carbon dioxide has come in the form of gases. So this is the answer for that question. Name any 4 enzyme catalyzed reactions. Inversion of sugar, enzyme is invertase. Conversion of milk to curd, enzyme is lactobacilli. Conversion of maltose to glucose, enzyme is maltase. Conversion of urea to ammonia, and that urease. Urease is the enzyme. Right? We'll go for the next question. Next question has come from principles in metallurgy. Right? General principles in metallurgy. From that, expected question only has come in this model paper. That is explain the purification of sulfide ore by froth flotation method. Explain the purification of 14th question. Explain the purification of sulfide ore by froth flotation method. Froth flotation method. Okay, sulfide ores purified by different methods. In one of them, froth flotation is one of the important one. Based on that, how can we purify that sulfide ore? Okay, so here we have to draw one diagram. Right, if you don't want to see this drawing of diagram, you can make this fast or forward, but diagram also important in the exam. Without diagram you can't get the marks. If you want to observe that, you can observe. Okay, we have taken one container. In that one rotating paddle we have to keep, a rotating paddle, right? This is the rotating paddle, contains like this. While rotating, to agitate that solution, okay, you can take like this. Here this can rotate like this. Here this is the rotation of this paddle, will be rotated like this. Okay, and one more gap also is there here. In this gap we are blowing the air through this air will come, air. Okay, because of the agitation it can form some froth. Here froth will come, this total froth. So those things, this is the froth. In the froth only we are collecting that sulfide ore. So how we are getting that I will explain. Okay, this is the froth. Okay, and we can send some air through this. Here also, yeah, sorry, here from air, here we are sending that pulp of ore, pulp of ore. This one is what? Rotating paddle, rotating paddle. Why we are using rotating paddle? Just to agitate that mixture of that suspension. Okay, so pulp of ore, and this one, it draws air, that fan type structure is there, right? That paddle draws in air and stirs the pulp. Paddle draws air and stir the pulp. You might listen about that making of butter from buttermilk, right? They will use this type of structure only. They will take one thread and they are moving like this, tilting like this. Then whatever the butter is present in the buttermilk, that will attach this. So this is the paddle draws air and stir the pulp. To stir that we are using this, just to stir. Okay, this total is what? This total is froth. Froth is nothing but foam. Okay, so now we will write that one by one point. First of all, this method used for what? That is the first point. This method is used, already given in the question, right? If not given, you have to write this point. Even given also write, nothing will happen. This method is used to purify sulfide ores. So this is the special method to purify sulfide ores. So first what we have to take? We have to take that powdered ore, of that sulfide ore we have to take, and we have to keep that in water. That is called as suspension. Means all the particles will not settle down in the container. So to agitate that suspension we are using what? Rotating paddle, a rotating paddle. A rotating paddle is used for what? To agitate the suspension. To agitate the suspension, what we have taken? Suspension of that what? Pulp of ore. Okay, suspension of pulp of ore with water. Pulp of ore with water. Okay, rotating paddle is using to agitate means what? To disturb, just to disturb, right? Now, one more point here. To stabilize that froth, we are using some stabilizer. So, froth stabilizer. Froth stabilizer means which stabilizes the froth, like cresol. So, what is the example for that? Cresol. And one more, froth collector means which creates more froth. Froth collectors, this is stabilizers. Froth collectors like pine oil. So, because of the pine oil, more and more froth will come. Pine oil are added. So, to that suspension, we are adding these two. One is to create the froth, and another one is to stabilize that froth. Okay. Now, when we agitating like this, all the sulfide ore particles are very light. So, all that gang particles means contamination will settle down in the bottom of the container, and because of the light weight of the sulfide ores, all of them will go and they will touch that froth. In the froth they are there now, in the froth. So, all these particles are sulfide ore particles. They are present in the froth. So, you can write that the mineral particles wet by oil, the mineral particles wet by oil means gang particles are what? Gang particles are wet by water, not oil. The mineral particles wet by oil, those are present in the froth, right? Oil present in the froth. So finally, what will done? After that, sulfide ores will come means what? We have to remove that froth first. Means we can use that word skimmed off. All the froth is skimmed off. Then we will dry that froth. Means after some time, what will happen when we are keeping that in the hot sun? All the froth will be evaporate, and the remaining particles are what? Sulfide. Those we have to collect. So finally, we have to write that froth is light and that will skimmed off. Right? When we are drying that, we will get our required sulfide ore. The froth is light and skimmed off. Means we removed, skimmed off, and dry that froth to collect purified sulfide ore. So this is a experiment which is very easy, right? Just to you understand this first, then you can write on your own words also, and diagram also should be there definitely. Okay, because of that rotating paddle, we just agitate that mixture suspension. Because of that, froth will come, right? And froth, in the froth, that light particles, sulfide particles are there, and we have to add the stabilizer and collectors. That point is should write. Finally, we have to dry it to collect that purified sulfide ore. Got it? The next question, we'll go for the next question. Next question has come from, that is P block elements. P block. So from the P block elements, 18th group it has given. 18th group means you can remember what is the question, you can guess. Mostly from the 18th group, they ask questions from the fluorides of xenon. Correct? So he asked that how are XeF2 and XeF4 prepared? Give their structures. Very simple. How are XeF2 and XeF4 both? So this is the which question? 15th question, right? Yeah, 15th question. How are XeF2 xenon difluoride and XeF4 xenon tetrafluoride prepared? This is the half of the question. How are XeF2 and XeF4 are prepared? If you write the preparation method of each one, you will get 1 mark, 2 marks. Then he continues the question that give their structures. You have to draw their structures also. Give their structures. So here XeF2 prepared. Preparation of XeF2. Number 1, preparation of XeF2. Just we are adding xenon and fluorine, you will get this. So Xe plus F2, that's it, gives rise to XeF2, xenon difluoride. Here xenon we have to take excess amount, more amount of xenon we have to take and less amount of fluorine, then we'll get that xenon difluoride. Here the conditions, the pressure we have to apply 1 bar and the temperature we have to maintain 673 Kelvin. That's it. Xenon reacts with fluorine at a temperature 673 Kelvin and 1 bar pressure to give XeF2. Next, preparation of structures we will discuss later. Preparation of XeF4 xenon tetrafluoride. So Xe plus F2 gives rise to XeF4. Okay, so this is called xenon tetrafluoride. Xenon tetrafluoride. Here the difference is here we have to take this in the ratio of 1:5. That is one thing. And temperature and pressure also we have to change. Here more than this 873 Kelvin temperature, and here also 6 bars more, means 7 bars. 7 bar. Then we got that xenon tetrafluoride. Now structures. Structure of XeF2. Structure of XeF2. So what is the structure? You have to remember that, otherwise you can do like this. X means containing what? 8 valence electrons, and it required only 2 fluorines. Remaining all of them are lone pair of electrons. Correct? 1, 2, 3, 4, 5. Total 5. 5 pairs means that is which hybridization? sp3d. So sp3d hybridization with 3 lone pairs. sp3d hybridization with 3 lone pairs. Then what is the structure? We'll get the linear structure. Linear structure. F here also F. So what is the structure? Structure is linear. Linear structure. Hybridization is sp3d. Means what here? All these are lone pairs. All the 3 lone pairs we have to mention here. Okay, 3 lone pairs here. This is one lone pair, another lone pair, another. This is the structure, linear structure. Okay. Now, if you take XeF4, what will happen? Here, 2 more fluorines, right? Fluorine, fluorine. Now, how many electron pairs? 4 bond pairs are there. 1, 2, 3, 4. 2 lone pairs are there. 5, 6. Total 6. sp3d2 hybridization. So, structure of XeF4. I am writing here. Structure of XeF4. Hybridization what? sp3d2. sp3d2 hybridization with two lone pairs. Two lone pairs. LP means lone pairs. Structure is what? Structure is square planar. Structure is square planar. Square planar structure. Right? So how can you draw this? X, E, F, here also F, F, F. This is just like square. Correct. X, E, F, 4 square. And remaining two lone pairs are here. One is above and another one is below. These are the two lone pairs. This structure is called what? Square planar structure. So that's about the preparation methods. This is just for rough preparation methods, and two preparation methods of each one preparation methods of XCF2 and XCF4, and structures also we have given. Those structures, one is linear structure, another one is square planar structure. Okay, the next question we'll go for the next question, that is from coordination compounds. In the coordination compounds, very important question. That is IUPAC nomenclature of coordination compounds. Correct? He has given 4 compounds, coordination compounds. Now we have to write that systematic names, right? Using IUPAC, 16th question, using IUPAC nomenclature, IUPAC norms, write the systematic names of the following. Write the systematic names of the following. Names of the following. First one given that you practice so many times, I think so. CONH3 taken 6 and Cl3. Second one, FeC2O4. C2O4 is what? Oxalato, right? -3. Third, FeCN taken 6 -3. Cyano, that one is cyano. And fourth one, NiCl4. Here, whatever the complexes, all of them containing monodentate ligands only, except the second one. Second one is containing what? C2O4. This is not monodentate, bidentate negative. C2O4, NH3. Okay. Here also CN, cyano. Here Cl4, chloro. So how can you write? How many amines are there? Total 6 are there, right? So that is why it will come as hexamine, cobalt. Now oxidation number you have to write. Oxidation number, 3 chlorines are there, each one 1. So total 3. Cobalt 3, chloride. Finally we have to write that chloride. Don't write trichloride. Whatever there out of the coordination entity, no need to mention that how many are there. Even potassium is there means you should not write the tripotassium, only potassium you should write. Okay. Next one, C2O4 means I told you that bidentate ligand. Whenever bidentate ligand, that prefix will be changed. In the place of bi, di, tri like that, tris, bis like that will come. So here 3 are there, that is why tris. And you have to write that in the bracket. That is the rule. If you read the rules, you will get trioxalato ferrate. Why ferrate has come? Because charge is there. Whenever negative charge is there means you have to add 8 to the metal atom. Ferrate. And here also 3. And whenever charge is there, either positive or negative, you have to write the ion. So all of them will get ion only. Okay. The next one, cyano, how many are there? 6. So hexacyano, again negative charge, that is why ferrate. So here 6 are there, 6 minus 3 is what? 3. Here also same like that. Here bidentate I told, 3 2s are 6, 6 minus 3, 3. Here 6 into 1, 6 minus 3, 3. Ion. Okay, we can't explain clearly, but you remember like that. Now this one, chloro, tetrachloro, nickel, negative charge is there, nickelate, and oxidation number 4 here, 4 minus 2, 2, nickelate 2 ion. So that's about the nomenclature of coordination compounds. Okay, the next question, 17th question. That 17th question has come from biomolecules. In the biomolecules, most expected question is vitamins, then hormones. Correct? Now the question has come from based on hormones. He is asking that what are hormones first? What are hormones? And you know that what are hormones? And question continue like this. Give one example for each. Give one example. Give one example for each of the following. So he has given that steroid hormones and polypeptide hormones, and finally the third one he has given that for each example you will get 1 mark, and for definition of hormones also 1 mark, total 4 marks. So amino acid derivatives. So he has given. So example for this we have to write, examples for this we have to write, examples for this also. Steroid hormones, polypeptide hormones, and amino acid derivatives. First, what are hormones you should write? Hormones are what? Chemical substances which transmit message from one part of the body to another part of the body. Right? So those are called as hormones. So we can write that the chemical substances which are used. So the answer, hormones. The chemical substances, they are present in the body, of course. The chemical substances which are used. So used for what? Transmit the message, right? So used to transmit or transfer, to transmit the message from one part of the body to other are called hormones. So the chemical substances which are used to transmit message from one part of the body to another part of the body is known as hormones. Now the remaining part of the question is what? We have to give the examples. Okay, chemical substances which are used to transmit the message from one part of the body to other are called hormones. Will get 1 mark. Now for that remaining 3, we have to write each one example. Okay, so you can write that steroid hormones example is, you can write testosterone, For polypeptide you can write insulin, And finally, amino acid derivatives, you can write that for amino acid derivatives, any one you can write. Epinephrine. So this is the example for amino acid derivative. Testosterone, insulin, epinephrine. That's it. Very simple. So when they gave that names of the hormones, no need to remember them. Sometimes they may give that what are hormones, give examples for different types of hormones. Then you should remember this also. Steroid hormones, polypeptide hormones, amino acid derivatives. Then you have to remember these three also, of course. Okay. Right. Finally, hope you got it, you copied. Okay. The last question of this section, 18th question. That 18th question has come from organic chemistry, that is haloalkanes and haloarenes. The question given like this: which compound in each of the following which compound in each of the following pairs will react. So to answer this question, to react faster, you should know the properties of SN2 reaction. Faster in SN2 reaction with OH minus. OH minus is what? Nucleophile. Okay, OH minus is the nucleophile. Which compound in each? So the first one given that, number 1, CH3Br or CH3I. This is the one. Second one, CH3 taken thrice, carbon Cl or CH3Cl. So which compound in each of the following pairs will react faster in SN2? If you know the properties of SN2 reaction, you can answer this easily. In the first question, observe that, try to understand. In both of them, one CH3Br is there, CH3I is there. In that, which one is reacting faster in SN2 reaction? That is the question. Here also two are there. In these two, which one react faster in SN2? Okay. So for the first one, property is here. The reactivity order, CH3, difference is what? Halogen. Bromine here, iodine is here. So we can answer like this. The reactivity order of halogens according to SN2 reaction. In SN2 reaction, so that order is I is greater than bromine, then chlorine, then fluorine. So this is the order. So in SN2 reaction, the reactivity order of halogen is this, means in this which one is faster? Therefore, CH3I is faster in SN2 reaction with OH minus. This I wrote. Will react. CH3I is faster in SN2 reaction with OH minus. Right? Half of the answer completed. Now here also chlorine, here also chlorine. Both halogens are same. But what is the difference? The difference is alkyl group. Here this one is primary alkyl. This one is tertiary alkyl. That is the point. So now, based on that SN2 reaction, the reactivity order of, here halogens were read. Here what you have to write? Alkyl halides in SN2 reaction. Alkyl halides in SN2 reaction. So Here tertiary is greater than, sorry, SN2 reaction. Primary is greater than, secondary is greater than tertiary. Okay. So based on this, you can answer this. Which one is faster here? The first one is tertiary, second one is primary. So which one is faster now? The faster one is primary. That is why you can answer this. Therefore, CH3Cl, in bracket you can write primary, is faster in SN2 reaction with OH minus. That's it. So which compound in each of the following pairs will react faster in SN2 reaction? Means here iodine. Why? Because reactivity order is like this. Iodine is greater than, bromine is greater than, chlorine is greater than fluorine. Here reactivity order of alkyl halides is what in SN2 reaction? Primary is greater than, secondary is greater than tertiary. So primary is more faster when compared with secondary and tertiary. Okay. So that's about short answers, 4 marks. Hope you got this. It will help you.